Plotting graphs with Matplot part 2. We have to again import pyplot for Matplotlib because we are on a different notebook. So we import pyplot from Matplotlib as plt. We will have to handle arrays, and we need several scientific functions. So numpy as np. And let's first generate our data, the data that we want to make plots with. We recover this for x and y. So lean space starting between 0 and 10, 100 points. And for y, the sign of x. Okay. And let's start for the new type of plot that you can generate using Matplotlib, which are logarithmic plots. Let's first create a new figure, and in this figure what we want to generate is this. Okay, one plot and then another. Here on the y-axis we want a logarithmic scale, and here a normal scale. On the bottom one we want a log-log plot, which means a logarithmic plot, a logarithmic scale on the y, and a logarithmic scale on the x. And let's start. So let's first generate a semi-logarithmic plot, where we will apply a logarithmic scale on the y-axis. Okay. We will sum x plus 1. This was the x plus 1 on the x, because 0 is undefined. Okay, we will have a 0 here, and when we apply the logarithmic of this, it's undefined, and we don't want that, so x plus 1. Okay. The y-axis will be, when we say semi log scale, the y-axis will be logarithmic, and this will be a normal scale. So we will apply a logarithmic scale to the exponential of x, which will give, of course, a straight line. And this is what you see. Very nice here. The second, then we add a title to this first plot, and then we pay show for it to appear. Then a second figure. We create a second figure right after the first one, and it will be a log-log plot, which means logarithmic scale on the x and logarithmic scale on the y, on the exponential of x. Okay. So the log-log plot would appear like this. Now we can see it growing exponential on the y, even though we have a logarithmic scale here, because we also have here a logarithmic scale. Let's try to generate this plot and show some differences. These two plots actually. Figure. Okay. And PL. We have to generate first here, because this is a different notebook. Import matplotlib by plot as plt. Mat. Okay. Import numpy as np. Let's see. It's still charging it's okay. And now let's generate the data. If not, it wouldn't work. In space. When you start doing data science or machine learning projects, this will be a dataset. This can also be, for example, your experimental data that you have if you measure something in the lab. Logarithmic plots, and let's now generate this. PLT figure, PLT semi log epsilon x plus 1, not to give an error because of the 0. And it's alright, I think. Yes. Let's go PLT title semi log plot on epsilon axis. This is important. If instead of an epsilon here you will have an x, this will be a normal scale and this will be the logarithmic scale, the x. Okay. It's PLT show. And now another figure for the bottom one. Figure PLT log x plus 1 and p exponential scale, both of them. Let's give a title. Log plot and PLT show. And let's check the result. Nice. See if it's exactly like this. Okay. Now let's change something here just to play around. Take this opportunity. See what will happen here. Should be fun to change entirely this. Exactly. Okay. This is the expected behavior. If we didn't have a log scale here and we apply a log scale here. Let's leave it as it is. Let's try to go for an error. Okay. It actually worked. You find a way to resolve automatically this. Python. Maybe some assumption that it made not to have an error. Or just generated a whole plot except one of the points and still got on with it. Okay, but this is it. Okay. Logarithmic plots you can do with Matplotlib. Let's go here. For the second type of plots, more advanced grid of plots. What we mean? 4 different plots side by side. It's just what we mean. Different functions. But that's not the important part. The important part, a grid of plots. Very clean. Okay. It will be more difficult to do this, for example, using Excel and then put on a Word. No, you do this automatically. Very easy. And check how aligned are the scales. Okay, the spacing. It's very difficult to do this without coding. So let's first here see what it means. We first generate subplots, a figure and then the axis. Subplots we want two rows, two columns, the width 8 and the height 6. Width 8, height 6, 2 by 2. For the first one, 0, 0, we are referring to this. This will be 0, 1, 1, 0, and 1, 1. 0, 0, we plot x and the scene of x, and we give a title. Set the title here as sine. For the 0, 1, the one on this side, we define the x and cosine of x, and we use as the title cosine. For the 1, 0, the one in the bottom right here, it's a tangent. We use we represent the x and the tangent of x. And the bottom right plot, 1, 1, we use an exponential decreasing plot. Okay, and we set the title. And very important, when you do this, if you want to automatically adjust the spacing between subplots to make everything fit nicely without overlapping, you use tight layout. If you didn't use tight layout, this could overlap here, the titles could overlap with the bottom of the graphics, and or you would have much more space. Here with tight layout, everything fits very neatly, and this is what you want. And then you show the plots. Okay, let's start right here. You could also define the spacing, but with tight overlap it does this automatically, and everything looks beautiful. And let's do this more advanced. This will take a while, but it will be worth it. So now you know that there's this capability, and you also know what it does. Fix size. Let's keep this one because it's optimized. We can then change, but nothing good will come of it. Zero. Plot x and p scene of x. It's okay. Let's give titles because it's easier to analyze. Let's not skip that. Set title here. Sign. Give a spacing. Let's go for this one. For the second one, 0, 1. Plot x and p cosine x. 0, 1. New title set. For this one, title cosine 1, 0. The tangent one on the bottom left. And now the bottom right. Let's go for it. exponential, negative exponential. Okay, and now let's build the tight. We have here tight layout, BLT show. Let's do the plots. Nice. Okay, and now we can try to mess this up a little bit. Let's try to not do this. Let's see if it also, it's the default. It can be the default. No, it's not the default, you see? This optimized everything, even the size of everything in the space for it to fit nicely. If you don't, it starts to overlap a bit. Okay, it's quite nice. So, let's see if we didn't show one of them, if it will be empty. Yes, it will appear the graphic, but the axis, because we already set the axis, but without anything inside, without the plot. This is just a plot. The spaces we define it here at the top. Now let's mess up the spaces. Let's put 16. Yes. Okay. Long here, but short on the height. Okay. And that's it. Let's now go for the next type of plot. Plots with multiple axes. Okay. What we mean? The same plot, okay, the same, inside the same plot, but two graphs with one for this axis and another one for this axis, okay? And then the x-axis. And let's see how it goes. So we basically create a figure with subplots. We create a twin x-axis, okay? You already knows with this way that we have two axes. The first axis on the left, it's for the, we want to represent the sign in the ipson axis, the sign of x with numpy, always with numpy. And this means that how we want to represent it in green with a solid line. The second one, we want to represent the cosine, but we wanted it to be in blue with a dashed line. And then we set the labels. We call this sine, set the labels. We mean this, the labels for the axis, for the ipson axis. For the first one, we set it to be green. And the other one, the second one, we set it with the same instructions, set ipson label with, for the cosine, with the color blue. Okay, it makes it visually clear which axis belongs to which line, and then we show the plot. Usually without this, without changing the colors, we would have probably this in black and this in black, and we wouldn't know which axis belongs to which plot. Okay, and this is quite a problem. Sometimes we see this and we have to guess. People don't change this color here, and we have to guess which axis belongs to which plot, and it's a nightmare. Let's see, let's represent right here to see if we can learn something more. first one will be a cosine. The second we want dash, we don't want red, blue here. Exactly. Let's go a bit back. Okay, this is done. Set ipsum label. Let's call it sign. A color. The color we want to be green. Cosine, and we count the color blue. Exactly. plt point show. Okay, and there you go. Quite nice. You could change the color here. Let's try red. Exactly. And it could be a dotted line, for example. Yes. Okay. Nice. Another type of graph, not another type, but what you can give is also mathematical and Greek symbols to your plots, especially to the axis. And let's first generate a plot, x versus y, and I versus x. Set the plot title using a latex style math formatting. The prefix R with the commas at the top creates a raw string, which is recommended for LaTeX. Inside these symbols, the dollar symbols, you can write mathematical expressions. And this, okay, let's see what this is. We are talking about the title. The R inside this, it's a raw string, which is used for LaTeX. Inside this, you write a mathematical expressions, which means that sin and the epsilon will appear as mathematical symbols and not standard text. And this here makes it appear not written theta, but as Greek letter theta. Let's see what I'm talking about. Greek letter theta. Okay, for this. Epsilon as a mathematical expression, equal as a mathematical expression, and sign. This is as a symbol. And then for the X label, we also do the same. Raw string for LaTeX, and the theta. This will be a mathematical expression, and theta will be the symbol. It's right here on the X. Okay, gives the symbol, and then rad appears as it is. We label also the epsilon axis, raw string for the epsilon label. It's for the X, this is for the epsilon, and this means that will be rendered, will appear as italic. Okay, and then we show, and we have here the graph. Let's recreate right here. Okay. And now, yes. and it's fine. Not sure just yet. X label R dollar symbol, and let's do theta dollar symbol rad inside the brackets. Let's see if this is alright. A lot of weird writing here. Let's go now plt epsilon label. This is what I want without. You already know if you want to autocomplete some text, just click on the tab and it will complete. And I think this is the right. No mistake. Let's try here to play a little bit, but we could try to take out the italic. Okay. And this will be with italic. See the changes. It doesn't change a lot. Okay. Just that now you know how that you have a way to, instead of writing theta or mathematical and Greek symbols, you have a way to input that as the symbol itself. And actually that's it for this second part. Thank you very much again. See you on the third part.